Mm, So we can start our session. So Bhargav, please start the session.
Okay, ma'am. Ma'am, can I start sharing the screen? Hello, ma'am. I am audible.
Yes, Bhargav, yes.
Okay, ma'am. Ma'am, PPT is visible, right?
Yes, Bhargav, you are on.
No, ma'am. My PPT is visible, right? Okay, ma'am. Good morning, ma'am. Good morning, guys. Today we are presenting about the assessing the energy sustainability quarter and impartial study on energy productivity from BRICS nation. So, myself, Bhargava Jampa. I am from Amrita School of Business. Coming to the goal 7 of this, ensuring access to affordable, reliable, sustainable, and modern energy for all. This is the sustainable goal 7 main aim. Coming to the fact sheet of this, affordable cleaning energy by 2030, universal access to affordable, reliable, and modern energy services, and then increase sustainability, the share of renewable energy in the global energy mix by 2030, double the global rate of improvement in energy efficiency, and how they are enhancing international operations and to facilitate access to clean energy research and technology, and extend infrastructure and upgrade technology for supplying modern and sustainable energy services for all in development countries. And the main goal is to promote peace, security, development, and cooperation. Coming to why BRICS, BRICS nation is involved in the social and economic development happens with energy efficiency attained, which in turn helps to attain sustainability with clean energy for the environment. And coming to all close relationship exists between the energy conservations and environmental protection from achieving sustainability. Coming to energy intensity signifies the amount of energy consumed for attaining energy productivity. In this study, we would like to access whether the energy productivity of the BRICS nations is related to the energy intensity, followed by investing in energy by private partnerships and attained for energy efficiency to attain sustainability. Coming to seek the sustainable deeper between the member nations and corporate economic expansion, including trading. Coming to the research questions, the first research question is how does having clean energy uh, relate to attaining sustainability goals for BRICS countries? Coming to the second research question, which BRICS nation are lead in SDG research? Coming to the third one, which variable is linear and non-linear in the attained of energy productivity for BRICS nation? Coming to the review of literature, studies has extended efficiency at the national and regional levels to track SDG development, and the indicators used were power generation from renewable energy sources and fossil fuel energy and alternative energy, unemployment, and GDP per capita. Demonstrating the uses of renewable energy enhances environmental quality, and BRICS country are emerging economic with larger population and concentrating resources, and the BRICS countries accounted for 41% of global CO2 emissions, and the responsibilities to reduce them in high. Coming to the limitations of the study, study is limited to BRICS nation, energy productivity and intensity, public-private partnerships in energy and energy efficiency. Coming to the time period of the study, we did 2017 to 2023, and data was collected from the secondary source from government database. Coming to the next slide, research methodology, and The study hypothesis is a test where each independent variable productivity has a linear relation with the dependent variable, such as energy efficiency, energy intensity, and investment in energy with private partnerships. Coming to the convenient sampling is applied to collect the data from analysis. Coming to the third point, different multiple criterion decisions are econometric models like linearity test, correlation matrix criteria, and non-linearity criteria to test whether the energy productivity variables influenced the SDG 7, Sustainable Development Goal 7 for the BRICS nation. Coming to the findings we did in this search, the first related to the scope of our cleaning energy and attained SDG 7 for BRICS nations in terms of investing in energy efficiency and intensity. Relating to the productivity, we found that energy intensity and energy investment in private partnerships have relevant evidence for BRICS nation. Uh, and coming to the Indian rank in the sustainable, India is ranked third in sustainable energy ranking, but there is an argument focusing on energy productivity. Coming to the last slide of our presentation, uh, we employed that there is a linear relation between energy productivity with energy intensity and investment in energy by the private partnerships. And there is non-linearity from energy productions, where the other three variables, the result relieved the BRICS nation need to focus on energy efficiency and attain sustainability. And thus the study suggests the BRICS nations should pay more attention to achieving sustainable energy efficiency and further study may be extended in the terms of period of study and adding energy variables focusing on energy emissions. Thank you, ma'am. We're done with our presentation.
Do you have your reference site?
Uh, Ma'am, can you repeat, ma'am?
Reference slide.
Reference site.
Yes. Which latest
Uh,
paper you have used for your this research?
Ma'am, can you repeat it again? Reference slide, ma'am, you're asking?
Yes, references of your paper. Can you show me?
Okay, ma'am. Ma'am, I did not added
Okay,
references
which
in this slide. Can
which latest paper you have used for this research? What is the year of
one
that paper?
uh, 2017 to 2023, ma'am.
Okay, so at first tell me which countries involved in BRICS.
Okay, ma'am.
In BRICS
Russia,
nation,
in
which countries are involved? Russia.
Russia, India, China, South Africa, and this one B for Brazil.
Brazil. Okay.
Ma'am,
Uh,
Brazil. Can I repeat, ma'am? That's okay.
yes.
Brazil, Russia, India, China, and South Africa.
Only these five nations are involved here, or any more nations are also there?
Ma'am, still now these five are involved, ma'am. Now Pakistan is trying to join the BRICS nation.
No, you checked. There are more four countries are there involved in this BRICS. This year they have involved here. Okay.
Oh,
So
uh,
next question is, could you discuss any limitations or challenges encountered during your research process, particularly in gathering your data or conducting analysis with these BRICS nations? Means, how did you address these limitations to ensure the robustness of your results?
Ma'am, we did, in the study is limited to the energy productivity and energy intensity by the public-private partnerships, ma'am, by the energy efficiency, and we collected the data from the Bloomberg database.
Okay. Clean energy means what?
Ma'am, clean. Clean
Everywhere
energy
you have
means
mentioned clean energy.
yes, yes, ma'am. Clean energy is energy that comes from renewable and zero emission resources that did not pollute the atmosphere when used, and as well as energy saved by efficiency measures.
Okay. Now, last question. You mention in
Okay,
your
ma'am.
paper that linear relationship between energy productivity and the two variables. So those two variables are your energy intensity and investment in energy by private partnership, right? And
Yes, ma'am.
non-linear relationship for energy production with other three. So can you explain the potential reason behind these specific observations?
Uh, ma'am, by this specific observation, the amount of energy used to produce and give you a level of output by the energy what we are producing, ma'am. These are the main. And using less energy to produce a product and providing a service results to reduce the energy intensity, ma'am.
Okay, fine. We can go. Yes, thank you, Bhargav.
Thank you, ma'am, for giving this opportunity to present my paper. Thank you, ma'am.
Okay, good. Now next,
Thank you.
we can start the next.
Hello, can somebody confirm if I'm audible?
Yes, yes, Richa ma'am, you are audible.
Hello? Hello?
Hello.
Yes, am I audible, ma'am?
Yes.
Okay, I'll start sharing my screen now.
Yes.
Mm. Mm. Is my screen visible?
Yes.
Okay. So good morning to all the panelists, dignitaries, and my fellow researchers. I'm Niveda Pagdhare, a final year student pursuing Bachelor's in Electronics and Telecommunication from SCTS, Pune Institute of Computer Technology. I'm here to present our paper contrasting approaches for Vedic multiplication using Xilinx ISC and Cadence on behalf of my fellow authors Prachi Whitaker and her Mr. H.S. Thakkar. This presentation will cover our topic, Vedic multiplier, the methodologies we adopted, and the results derived from the study. So let's get started. Vedic mathematics originated from the ancient Indian mathematics, revolutionized the traditional arithmetic by introducing faster and reliable computational methods. Comprising of 16 sutras or principles, one of its notable techniques is Urdhva Triyagyam, the 14th sutra utilized for the creation of Vedic multiplier. The Vedic multiplier employs vertical and crosswise method, leveraging the Urdhva Triyagyam principle. This method facilitates quicker and more efficient multiplication operations compared to the conventional algorithms. To answer the question why Vedic multiplier, one of the primary reasons for adoption of the Vedic multiplier is its ability to simplify various numerical operations. Furthermore, the Vedic multiplier demonstrates a slower area and delay growth, indicating its efficiency in terms of hardware implementation. As the number of the bits increases, the efficiency of the Vedic multiplier improves further. This scalability features also allows it to adapt to different computational requirements. So in our research, two methodologies, that is the algorithmic approach and the block diagram approach, were implemented using Verilog modules to design an 8-bit Vedic multiplier, examining its design and working principles. This demonstration showcased the effectiveness and usefulness of Vedic multiplier in digital circuits. Firstly, in the algorithmic approach, a behavioral modeling style was employed for efficient addition and multiplication tasks, utilizing temporary signals in Verilog model. This methodology enhanced mathematical operation performance in 8-bit environment through the implementation of specific Vedic multiplication instructions. As shown in the example below of 2-bit Vedic multiplication, the algorithmic approach directly implements the vertical and crosswise method with the help of Verilog language. By storing the multiplication results in temporary variables and then performing the addition of the carry accordingly. Moving forward, another approach implemented was the block diagram approach. It implemented the structural modeling style, which showcased the hierarchical structure of 8-bit Vedic multiplier. As shown in the figure of 8-bit Vedic multiplier, consists of 4 modules of 4-bit Vedic multipliers and adders of different sizes for particular bit addition. Similarly, each 4-bit multiplier consists of 4 blocks of 2-bit Vedic multipliers and adders, where 2-bit Vedic multiplier consists of 2 half adders. Now, moving forward to the results and discussion sections, the implementation results from 2 different tools, namely Xilinx ISC and Cadence, were compared. The simulation and synthesis were carried out on Xilinx ISC, which relied on the FPGA implementation, and the physical implementation was carried out on Cadence tool, relied on the design metric of the integrated circuit. Now, according to the results obtained from the Xilinx ISC, the block diagram approach performed better than the algorithmic approach. The bar chart shows the results, which indicates that the block diagram approach proved to be more efficient in terms of timing constraints than the algorithmic model, but the algorithmic approach had lesser device utilization. The higher number of adders in the algorithmic approach reduces its speed, while the complexity of the block diagram approach increases its device utilization parameters like slices and input LUTs. The power required for both the approaches is the same. The next slide shows the visual representation of the area, power, and speed analysis of both the model obtained by the reports generated during the semi-custom IC flow carried out using Cadence tools, namely in Cadence Incisive, Cadence Genus, and Cadence Innovus. The area report indicates that the block diagram approach uses higher area as compared to the algorithmic approach. The block diagram approach increased the power utilization, but the switching losses were generated more in the algorithmic approach. And now coming to the timing constraints, the block diagram model performed better with respect to timing constraint by providing a positive slack, meaning that the part met the timing constraints. As discussed earlier, the result from the Xilinx model simulation relied on the implementation of FPGA, and results obtained using Cadence semi-custom ASIC flows tools utilized design metrics of the physical integrated circuit. Xilinx FPGA simulation favored the block diagram method, showing shorter setup times up to 4.113 nanoseconds, and the block diagram model exhibited a 75% decrease in the number of the adders, enhancing the overall speed. The Cadence genus synthesis showcased the algorithmic model with 43.57% less area utilization and 43.11% low power usage. The block diagram approach outperformed the timing, delivering faster outputs in 1790 picoseconds with 4.22% decrease in the output time. The algorithmic model reduces the device utilization and the power consumption, but the block diagram model offers faster and more accurate results. These are the 7 references which we referred during our research.
So go to that slide
And-
before the conclusion slide.
Okay.
Okay.
Yeah.
So what is that negative value minus 3279
Okay,
slack?
so slack is the measure of if when the like a particular input reaches its output accordingly. For the algorithmic approach, apparently the slack was negative.
Okay. And your launch clock started at 0, right? And what uncertainty, how you calculated this uncertainty as 10 means?
Actually, these are the parameters which were generated in the report of the cadence timing report itself. We didn't calculate it, that this were the results derived when we created the physical implementation.
Okay. So can you elaborate on the specific benefits Vedic multiplication compared to this traditional multiplication methods, especially in this hardware implementation?
Okay, so in the Vedic multiplication, as shown before, like how it uses only a particular algorithm. So as compared to the normal traditional multipliers which are available right now, Vedic multiplier is supposed to be the fastest due to its efficiency of the algorithm, as well as it utilizes a bit lesser cell counts than the normal multipliers, like the adders or the accumulators which are used. There are specific decrease in the utilization, as well as it also increases the time, like the speed of the circuit.
Okay, so what is the full form of ISE, Xilinx ISE?
Uh, Integrated simulation environment.
Okay, so did you encounter any challenges in implementing this Vedic multiplication algorithm on either Xilinx ISE or this cadence tools?
Yes, actually during implementation of the one of the approaches, like the algorithmic approach and the cadence, at first we did encounter many of the timing constraints. So we had to adjust a bit in the clock speed, and also the other timing constraint we had to define properly in order to get the output, because we weren't getting a proper simulation waveform or the outputs which we are getting right now.
Okay, for the Xilinx, you have to write assembly language or any other language you have to use?
No, we use the Verilog language, which is Verilog, Verilog
Very
HDL.
okay,
Yeah.
okay. And for the cadence tools, is it simulation or
So in the Cadence tool, we did the simulation, and then with the help of the incessive, Cadence incessive, with the help of Cadence Incisive, we did the simulation, and then we physically implemented it using the Innovus and Genus software. Like in the Genus software, we did the RTL synthesis, and in the Innovus software, we physically implemented by putting the power rails and the standard cell placement.
okay? Good, Nivedita.
Thank you, ma'am.
Yes. Now we can start with the next.
So our next presenter is Kathirej P. And the paper title is Drop-off System Using Machine Learning for Drivers.
Yes, ma'am. Can I share the screen?
Yes, please.
Ma'am, is it visible?
No, still it's not visible. Yes, now it is visible. Yes.
Okay. Good morning to all. Our project title is Drop-off System Using Machine Learning for Drivers, and our primary goal is to detect the driver's drowsiness before they slept or tired of, but also alerting them and sending the message to the owners or the admin of the panel. Um One of the main factors in accident is death. A serious injury is comes from drowsiness. Detecting driver's drowsiness is crucial aspect of ensuring road safety. The minor signs of drowsiness like running, dropping, eyelids, drowning can lead to catastrophic consequences. This project presents a non-intrusive prototype computer vision system monitoring drivers' vigilance in real time. We use CNN for tracking eye and in real time. We have took a literature view from the 22 Rayad Albury. The title of the project is Fatigue State Detection for Tired Persons in Presence of Driving Periods. Here he used support vector machine learning, which collects, which need a more large data set, but it will be using lesser time to monitor. Here we have improved it with CNN, which only get a less amount of data, so the data set size is decreased. And another research paper is Animan Almin. Its title of the project is early identification and detection of driver drowsiness by hybrid machine learning. Here he also used a support vector machine learning. Here the camera resolution is quite low because it only detects the minimum pixels. um in that. But the accuracy is in illumination condition is quite high. Okay. The real problem is the safety hazard. The driver when slipped off, the accident prone is higher, and the system also alerts the driver whether he ready to drive or not by alerting him. And the model's inaccuracy are lead to this problem, and various symptoms are not accepted by many other projects and environmental factors also. This is our proposed system architecture. Here we capture the driver's face in real time, and using the aspect ratio and move the aspect ratio by data sets, it will calculate the whether he is in drowsiness or not. And if it is close, it sends alerts to him and also the owner. And again, directing drowsiness using CNN involves capturing analyzing facial features to identify signs of drowsiness. Design a CNN architecture that can extract features relevant to drowsiness reduction for facial images. It has convolution layers for future extraction and followed by fully connected layers for classification also. Innovativeness. These systems use computer vision techniques to analyze facial features like eye movements, blinking patterns. Uh, it will lively feed to the camera. By continuously monitoring these cues, the system can detect the signs of fatigue or drowsiness, and also detecting yawning factors like eyelid drooping and head nodding contributes to more accurate assessment for the driver state. These are the software and hardware requirements of our project. RAM size is 4 GB and disk size is 20 GB is required to capture the image, and we also require camera also. And in our project, we have three modules: admin, driver, and owner. Admin module is responsible for including user registration, data storage, and the overall system functionality. The admin module also oversees the update maintenance to keep the system running smoothly. This is the demo of admin module where you can log in. Admin can access information about registered owners and drivers, including contact details, vehicle information. Uh, in case he can access anyone's data. Uh, and second module is driver module. He is designed to monitor the behavior and vital signs of driver while he is operating the vehicle. He captures the facial data in real time using cameras, and it will be verified whether he is browsing and using convolutional neural network. And if he is browsing, it will send the alert to him. This is a driver registration module. Driver modules allow drivers to create accounts, and after the creating account, whether he can log in, the system will automatically capture his face and start it code, and it will provide a real-time alerts to the driver to prevent the potential accidents. And this is the owner module. We can register a number of owners under the admin module, and a owner can register a number of drivers under him. This module allows owner to create accounts, and this provides real-time updates on driver's condition. If a driver is in drowsiness, it will send the alert to the owner also. He can monitor it from his login, receive email notification about driver's drowsiness status, which ensuring timely intervention. And conclusion, the proposed system can be used for the driver safetyness and its consequences. The system detects drowsiness of driver through eye conditions. The proposed method was tested in video sequence recorded in vehicle as well as in lab environment. An alarm is triggered if eyes are found to be closed for consecutive frames. Therefore, it is suitable for implementing surveillance in surveillance environment. And our future work is to enhance it by advanced machine learning algorithms and different eye movement patterns and facial expressions. And that's all about our presentation.
Okay, Kathiresh,
Okay.
how does your system differentiate between fatigue-induced yawning and regular yawning?
Static induced learning The eyelids patterns and the head portion also will be detected.
This how?
Fatigue induced running means the head pose will be different, and if it is normal running means the head pose will be different, and eyelids also will be monitored.
Is it so? Is it really?
Yes, sir.
Okay, so can you elaborate how your CNN architecture addresses the illumination variation typically found in your real world driving scenarios? Means, for example, sunlight and tunnel entrances, etc.
Ma'am, our project has required some illumination, so it will not work under complete darkness. In tunnel and all, we cannot record the driver's video in
So
real
have
time.
right. So if in the night scenario it will not work, your model will not work in the night scenario.
No, ma'am, it's not like that. If it is completely dark, it can accuracy level can be reduced. Will be reduced.
Okay, so what is the computational cost of running your system in real time on embedded hardware platform typically found in cars? What
Cost
exact?
cost
What
implement.
sir? At what cost will require approximately for your system to embedded all these models in the car?
Around 20K to 30K it will be required to implement. Ma'am.
Only 20K are sufficient to
Yes,
handle
ma'am.
all these things.
Yes, ma'am. For the vehicle module, it will be sufficient. Ma'am.
What latency does your system introduce between detecting the fatigue and triggering an interventions? Example, your audio alert and haptic feedback.
Can you repeat? Me?
What latency your system introduce between detecting the fatigue and triggering an intervention?
Um,
Is there any latency to detect
no,
some
no, it
problem is
will.
going on?
Oh, it will be monitoring in the drive vehicle itself, so there will be no latency and issues in the monitoring. The entire system will be working on a vehicle only, so there will be no latency in monitoring drive.
Okay, ठीक है. Cut. Kathiresh, okay, you can leave.
Okay,
Thank you, sir.
thank you.
We can start with the next.
Moving on, I like to call Mr. Cjo Pierce for his paper titled Measuring Co-founding Bias in Mixed Multidimensional Data Case. Of course, multiple linear regression adjustments. Sir, you can start your presentation, please.
Thank you. I hope you can see my screen.
Yes, yes.
Hello, good morning. My topic is on measuring confounding bias in mixed multidimensional data. Myself, Sicho Arakalpaios. I'm an early stage researcher and a PhD student in Information System Group in Taltech, Estonia. So our motivation. The United Nations 2030 Agenda for Sustainable Development stress the importance of disaggregated data for monitoring the achievements of the UN sustainability goals. That means improving data disaggregation is fundamental for the full implementation and monitoring the achievement of UN sustainability goals indicator framework. Higher the data integration immediately allows for more precise, more fine-grained monitoring and control. As I said in the previous slide, higher data disaggregation immediately allows for more precise, more fine-grained monitoring controls. When it comes to the decision making, data disaggregation allows for more sophisticated reasoning as follows. The higher disaggregation of data, more latent variable becomes explicit. Therefore, the higher disaggregation, the better we can potentially understand confounding effect. We argue that the benefits of disaggregation of decision making can even be characterized as the essential improved potential to understand confounder. What is confounder? Confounder is a major concern in the research because it can lead to a researchers drawing wrong conclusions. When confounding occurs, it hides the actual effect of a variable being studied. Thus, controlling or eliminating this confounding influence becomes crucial to obtain accurate and meaningful results. A variable is considered as a potential confounder if it meets some certain criteria, like it must be connected to the target variable, it must be connected with the influencing variable and distributed unevenly among the influencing variable groups, and it must not be an outcome of an influencing variable. With the current study, we aim to contribute to the development of a tool-integrated support for understanding confounders in a data. We utilize multilinear regression adjustment features to identify the confounder. In experiment with the grant report, we conduct experiments on extended air pollutant dataset. In surveys of this, we first join air pollutant data of severe cities with carbon dioxide level. Furthermore, adding disaggregated data for various cities, then we utilize the tool to investigate the correlation between standardized air quality indexes and carbon dioxide level before confounder adjustment in regards of additional city data and after confounder adjustment in regards of the additional city data. So I have talked about the grant report before in the previous slide. So what is grant report? During our research, we realized that an analytical tool which can perform multiple data mining techniques in one click is missing. So we have created a grant report. This is a tool where with the one click, you can do multiple data mining techniques like regression, correlations, many more. Unfortunately, the inclusion of numerical data columns is achieved only by discretization in most of the today's data mining tools. This is a severe limitation because when it comes to the numerical data values, decision makers and domain experts want to base their argument on mean values. But in Grand Report, we have tackled this problem. We are not using the mean values. We are using it for the combinations, mean values, and this kind of stuff.
Hello.
Maybe sir left the meeting.
Okay.
Till he rejoins, we can take the next presentation.
Okay, fine.
So I'd like to call Mr. Aditya Srishat from Vishwakarma Institute of Technology to call his on the paper title Online News, Event Detection and Community Identification. Sir, you may please start now.
Hello, am I audible?
Yes, you are
Yes,
audible.
sir.
Okay. Wait a second, ma'am. Just 2 minutes. So is my screen visible, ma'am?
Yes, sir.
Yes.
Okay. So coming to our project, this is our project on online news, event detection and community identification. So good morning, everyone. We are students of Vishwakarma Institute of Technology, Pune. So this is the agenda of our project. So firstly, I will start with introduction. So as we all know that social media has a great impact on our society, and also when we look at Facebook, Twitter, or various news website, so we need a system so that we can identify the communities and group people based on that, and also we can identify the important terms in those uh, communities so that it can be used for future use. So basically communities means the people are means group based on their interest, maybe it be politics or cricket or anything. And also events are the particular words in those news headlines that cause a boom in that overall data set, means in increases the frequency rapidly. So we have used TF-IDF vectorization for it. And also coming to a problem statement, so we are trying to make a system that means basically generates output based on when we give it the data set. And also we have merged the community detection and event detection in the same website. So this is our literature review. So we have referred various papers, and from those papers we came to understand the basic concept that we can use for both event detection and community detection. So basically these papers use separately, means community detection was on separate papers and event detection was on separate papers. So we merged both of them and tried to make a project on it. This is the research gap that we found. So current research paper primarily focuses on either community detection or event detection, but we merge both of them and gave the output to the user. It's a user friendly website in the form of JSP and servlets, and we are running it on a server. So user can easily interact with the website and give its data to it. And also we are generating 2D and 3D visualization so that user can easily understand what is the output that he got. And also this can be used by various industrial purposes and also various other things. So this is the means flowchart of a project. So I will firstly explain you the methodology of event detection. So basically in event detection we take the CSV file as an input. We divide the data based on the dates that we got it, and we divide it into 5 days gap, and we introduce TF-IDF vectorization on it, and we do some feature extraction, and based on the values that we got we uh, arrange them in ascending order. And also when we arrange them in ascending order we get the important terms in the overall data set that we use for community detection. And we visualize it in using the pyplot library of Python in 3D, 2D, bar graph, and also so the user can easily understand. And also this is for community detection. So firstly we do community detection, and on that particular data we do event detection. So for community detection we use another technique in TF-IDF vectorization, that is a parse matrix. So parse matrix is when it is generated we can use algorithm, right, decision tree or random forest for its classification. So we use random forest because decision tree proposes a problem of overfitting. So we, for more flexible approach, we use random forest, and we generated that output, and from that output we extracted events, and we also visualize the data in the form of like this. These are the results that we have got. So national, international, politics, sports, these are the communities, means people, frequency of people searching this in the data set, and we have given here the percentage of it. These are for communities, and these are the clusters of communities, means the if the cluster is more, means more compact, then it tells that the number of viewers of those communities is more. We have also tried to show them in 3D in the form of 3D representation. And also for the events we have used the same approach, and for the sample result we can show you that this is for politics community. So here are the headlines of the news that we gave to the input, and this is the output that we got. For some are for entertainment industry, some are international, some are sports, and also these are the events that we got based on the communities. So these are some of the important terms like Trump, Donald Trump, police, death. This causes a means increase in the frequency of the news. Coming to a
So
conclusion.
just a gentle reminder that 8 minutes are over. So please can you wrap up a bit quickly?
Yes, ma'am. It is over now. Coming to our references. So these are the papers that we have reference. So just okay, ma'am.
Uh, Go to that 3D visualization slide.
Okay.
Means, can you explain how this visualization help with interactive investigation and analysis of the events?
Okay, ma'am. So when we give the data to it, so it forms a nodes of that particular data. So if the nodes are closely clustered, means that they are closely connected. So their density was more in the community that we have shown here. So based on that, it can be used in recommendation system and also for various future purposes by different companies, so that they can based on the search results of users, they can show that this was the result that we got and people are more interested in these things. So basically these clusters are just a half data because it was not fitting in the computer screen, so we have somewhat cut the data for more visualization.
Okay, so what is the use of this TF and IDF?
Ma'am, TF and IDF means it is a general formula which is term frequency inverse document frequency. So it basically means of a it basically converts the whole document into single words, and then it overall in the overall document it generates an output used on the formula of TF IDF, and based on that result we can, if the value is more, then we can say that the term was repeated more times in the document, and if the TF IDF value goes on increasing in a means exponential way, so that we can say that the term was suddenly the frequency has increased. So this helped us in event detection.
Is your system designed to handle the news articles in multiple languages?
No, ma'am, just English. Uh, right now it is just for English. We can enhance it in future.
Okay. So, in your system, you mentioned that the use of IDF, TF IDF analysis, then time series analysis,
Yes,
community detection, right?
yes,
So,
ma'am.
could you discuss how these methods work together to achieve the event detection and community identification? Means, are there any challenges or limitations associated with this integrating these techniques?
Yes, ma'am. So discussing about the model, we can train it more on the right now we had a little bit of data set, but if we use more enhanced type of data set, we can increase the accuracy of that model. And also when we did the sparse metric, so we face the challenges of trying different types of algorithms on it which will work perfectly. So we came to a conclusion that random forest should be the best for it. It was given the best output, and when the communities are detected, the same data set is given to the event detection algorithm, and it detects the events and generates the whole output in the form of graphs jpg files which user can download from our website.
Okay, okay, Aditya, you can
Okay,
leave. You can
thanks.
stop.
Okay, thank you, sir. Uh,
Now it's
Mr. Sijo, he left the meeting, so he wanted to continue the presentation. So,
yes,
sir,
yes.
you can continue it.
Thank you, thank you, thank you. Okay, so I will start my presentation once again. So is it okay if I'm starting from here or should I start from the beginning?
You can start
Hello.
from where you left.
Okay, I think I left from here.
Yes, this table was there.
Yeah, yeah. So for our experiment, we have used the meteorological data from China, the CMDC dataset. These datasets consist of various meteorological attributes like precipitation amount, sea level, pressure, snow depth, temperature, visibility, wind speed, and more. Additionally, the CMDC also provides data for the average air quality index for various cities across China. And we have collected the data for 1 year. In our experiment, the AQI from CMDC datasets has been used as a target variable. To conduct a useful confounder analysis, we have extended the CMDC dataset with additional parameters. Like we have added the potential confounders like the population density, gross domestic production, number of vehicles. So for this study, the target variable is air quality index, primary influencing factor, carbon dioxide level, potential influencing confounders, population density, gross domestic production, number of vehicles. So here is the results. To identify the adjusted regression line, multiple linear regression method is used with influencing factors as the input and AQI as the target factor. Then we performed a linear regression for each influencing factor with the target factor to identify the marginal regression line. Subsequently, we created the different combinations of primary influencing factor for CO2 by combining it with the potential confounders variable. By doing so, we aim to perform multiple linear regression to identify the effect of these potential confounder variables on AQI. In the process of coerced multiple linear regression adjustment, two types of regression lines, namely the marginal and the adjusted regression lines, are generated and then compared. The marginal regression lines involves the computation of the slope of each individual influencing factors and the target factor. The adjusted regression line is created by performing multiple linear regression using the combinations of influencing factors with the target factor. To quantify the influence of confounding, we calculated the percentage difference between the adjusted and marginal regression lines. As you can see, the population and GDP are the confounder in this experiment. So when the combinations of population and GDP comes with the CO2, it is impacting the air quality index. So the conclusion, the UN 2030 Agenda for Sustainable Data Development strongly emphasized the necessity of using disaggregated data to effectively meet its objectives. The integrated multiple linear regression adjustment in Grant Report introduced a potential mechanism to identify and account for confounding effect when analyzing complex dataset. This investigation was conducted both before and after adjusting for potential confounders using additional city data. The experiment conducted with the Grant Report provided compelling evidence of the viability and efficiency of the multiple linear regression approach. This research highlights the crucial importance of identifying and addressing confounding variables in data analysis. So it is always recommendable to analyze for inner layers and compare it with the marginal layer. Thank you.
Okay, good. Are there any limitations to your approach, such as assumption should the linearity of relationships or the number of co-founders that can be handled?
Currently, with the Grant Report tool, we are only taking one column as a target factor. So as I mentioned here, only the CO2, the carbon dioxide level is considered as a target factor. That's our limitation with the tool. But for the influencing factors, the primary confounders, it can be a combination. So in the future, we are planning to make it for the target factor also with the combinations.
Okay. So beyond the specific case study of the air pollutants data, do you see potential applications or extensions of your approach to other domains or data sets?
Yes. For a next step, we are conducting a study on 700 dataset from the hardware database. So we are conducting the same experiment with 700 dataset from different domains and trying to identify, okay, how the confounding effects are happening with this approach and how can be identified. And we are comparing with the UDA-Pearls method and Osaka blinder method. So we are comparing with other methods and we are doing it for a massive data, different domains.
Okay. So what significant changes you observed in the correlation patterns between this air quality indices and CO2 levels after adjustment?
So I think on the fourth line, population and GDP, when it comes to the percentage difference, the column on the sixth column, you can see the population and GDP combining with CO2, it's 6.73, and on the last line it was 7.24. So it's a significant change. It's happening from the marginal when it's combining with some other additional data. So from here we can say, okay, population and GDP has a significant role, or we can say it as these two are the confounding factors. But only when it comes it as a combination. When it comes alone with the CO2, it doesn't has any change. It's a minor change, so it can be negligible.
Okay. So are there any plans to explore integrating other methods for co-founder adjustment beyond this multiple linear regression?
Yeah, we are trying to identify a new method to identify the confounder with a improved formula. So we are on the working of it, and I hopefully it will be ready for the next time.
Okay. ठीक है. Thank you. Sejo,
Thank you.
you can
Thank
start.
you.
Thank you, sir. So moving on, I'd like to call Mr. Vunam Vamsi Krishna to present his paper titled Speech to Action for Assisting Deaf Communities. So you may please start now.
Yes, ma'am. Thank you, everyone. I think you can see my screen
Not yet.
No, sir, it's not visible.
now.
Now it is visible.
Yeah. Good morning, everyone. My name is Vamsi Krishna. I am going to present speech to action project for assisting deaf communities. So today I am going to present in brief introduction about the project and the problem statement we have followed, and the literature survey and the system model and implementation part of our system model, and the results we got from the implementation part will be discussed, and then we conclude with the conclusion. So communication is an essential component of human interaction and allowing it to convey thoughts, emotion, and information. However, the deaf community has inability to hear and understand spoken language and creates sustainable barriers in their daily lives. So deaf communication often experience isolation, limited access to information, and difficulties engaging with hearing world, and they're hiding personal growth and social inclusion. While sign language and written communication are indispensable tools, they may not always effectively bridge the communication gap for deaf individuals. So going to the problem statement, the project is all about making communication easier for deaf individuals. It does this by transforming spoken words into 3D designs using uh, using videos we got from Kaggle, And these designs not only represent the words being spoken, but also show the emotion behind them. So if someone is happy, sad, or excited, the design will reflect that. And this makes it more easier for deaf people to understand what being said and to join in conversion and activities. So it's like bringing spoken language to a life way that everyone, including deaf individuals, can fully participate in and enjoy that. So this not only make communication more inclusive, but also enriches the overall experience for everyone involved. So now the literature survey in 2021, a significant advancement in the communication of hearing impaired was achieved through development of a system that translates speech to text into continuous sign movements performed by a 3D avatar. The system concludes of three main modules. One is speech, converting speech to text into then text to English sentences, and the translating English sentences into sign languages using natural language processing, and rendering the ISL sentences into 3D movements. So they got an sign error of 10.5, and the system demonstrates promising accuracy in generating sign languages users and thereby enhancing communication accessibility for the hearing impaired. And further progress was made in 2023 with the implementation of hand gesture recognition system coupled with voice conversation technology, especially for deaf and dumb community. This this project utilizes OpenCV for hand gesture recognition, and MediaPipe and TensorFlow framework are employed for detection and management techniques. They explored various image processing methods and gained insights into fundamentals of neural networks also. So by the by using these two literature survey, we are going a new approach taken to develop a speech to action capable of interrupting natural language commands in real life, emphasizing context awareness and adaptability. This system also aims to facilitate seamless interaction between users and devices across diverse applications. And by integrating cutting-edge technologies like natural language processing and real-life adaptation algorithms, this project aims to enhance the versatility and usability of systems, thereby addressing specific needs and preferences of users, including hearing impaired community. Moreover, the incorporation of emotion into the final sign output adds depth and nuance to the communication, enriching the overall interaction experience for the users. So this was the system model used for speech recognition NLP text processing. So here the first input speech will be recorded using Pi audio module, and the audio will be processed using Google Speech API. Here Google Speech API will recognize the speech and it will convert to a text. So after the conversion of that speech to text, there will be a speech translation. Whenever the user will speak in native language or any Indian regional language, it will be converted into English. From English to it will be going to the pre-processing step of the text. So in pre-processing, we apply some of the NLP techniques like tokenization, parts of speech tagging, and lemmatization, and stop word removal. So after the pre-processing, we will get a processed text, and the processed text will be applied with animations. So how we are incorporating emotion to the final sign languages. This is the system model diagram for the emotion recognition. So here also the input audio will be recorded. So going to the pre-processing, we are going to extracting the MFCC features. So in MFCC features, there will be some kind of methods, framing, windowing, FFT, and Bellbank frequencies and DCT. So after the frequencies we are going to transform the frequencies into a image format and and data format, data in CSV format. So we are going to give a training of 65% for training and 20% for testing and validation of 15%. So the images MFCC extraction images were used for CNN, and the and normal CSV data is used for RNN. So because why CNN is best for image classification task and RNN is less for time dependency task. So for each time interval, the features of the audio will be recorded. So RNN is used for that also. So based upon the CNN RNN, we choose the best model and we'll test that model and we'll give the output of which emotion is we are getting for those audio. So going to the implementation part, our approach to speech recognition involves Google Speech Recognition Service. Initially, we capture input through a user interface and then pre-process it to enhance signal quality and reduce background noise. The pre-processed audio is then sent into Google APIs, which employs advanced machine learning algorithms to convert spoken words into text. For pre-processing using NLP, we apply several techniques. Tokenization. This process divides into smaller units such as words or sentences, make it easier for analysis. And POS tagging. This assigns grammatical rules to each word, which is crucial for synaptical understanding analysis. And lemmatization. This simplifies words to their base forms, aiding to consistent analysis by reducing different forms of the same word to a common base word. And stopword removal. This eliminates common words that
So
carry.
just a gentle reminder that 8 minutes are over. So please can you wrap up?
Yeah. So next part of our implementation is emotion detection. Here we are using test data set and we are using two models, CNN and LSTM. So for LSTM, we use because it can easily capture dependence in sequential data. So we are how we are adding emotion. So to enhance sign language communication with them, our approach involves adding video into two video frames, which are then converted into grayscale, and we identify faces in each image, and we apply angry or like kind of which emotion will be integrated with OpenCV. So going to the results, so here we can see this. The first image shows the video voice recognition functionality used by Google Description. Whenever the user said what is your name, it will recognize and give us a text. Then whenever the user speak in any regional language like Telugu or Kannada, it will translate into English. So this was the pre-processing of NLP. Here the tokenization, POS tagging, and stopwatch removal are happening, and the final pre-processing text is visible at the end of the image. So this was the results we got for emotion detection using deep learning. So here for LSTM we got 99.25 and CNN is 97.27. LSTM is more good. It can capture long-term dependencies. So this was the results we got. The first image shows that the provided visual representation of face were you processed by NLP system. Here there is no emotion in a face. So the emotion we got from deep learning model, we used it as we took an emoji of face of a happy or sad, and we applied it to using OpenCV to the above image. You can see below image it's showing an happiness emoji. So I am going to conclude now. In our project, we have created a system that turns spoken language into sign language while also recognizing the speaker emotions. Our method achieved an impression accuracy of 99.25 per emotion recognition, surpassing the existing research. This breakthrough not only make communication easier for the hearing impaired, but also helps understanding the emotion behind the words. And it's a big step in forward in making technology more inclusive and emotional aware. So these are the references I used to build this project.
Okay. Okay,
Thank
Vamsi. The question for you is you
Yes.
mentioned the extensive feedback loop, right? So can you elaborate on that data collection methods and how the feedback is used to improve the system performance?
For emotion recognition.
Yes, you somewhere you mentioned extensive feedback loop, right?
Yes, ma'am. Basically, LSTM, whenever it faces an error, it will go back to until it get a correct output, it will go back and back propagate and it will give the correct output. So for this method, it will give as a 99.25 as a good accuracy.
Okay. What is the adaptive learning?
Adaptive learning, it's like it, it's a time series data, ma'am. A speech is a continuous time series data. For each second, there will be a future. So LSTM can easily recognize uh, futures in a time series data set. So LSTM is more adaptable to time series data set.
Okay. How did you measure the accuracy of your system in sign language translation and
Yeah,
emotion recognition?
yeah. For in emotion recognition, we'll use accuracy, precision, and F1 score like kind of this. And for sign language, there is no kind of. So typically, basically we are for text we are giving some emotions which already we have in a video format. So there is no any calculation method for this. So but we took some reviews from 10 hearing impaired people. So based upon the reviews, we will calculate our model.
Okay, so is there any plan for you to
Yeah,
integrate the two-way communications,
yeah,
allowing users to translate the spoken language into sign language as well?
yeah. Previous semester we did speech to sign language. Now we are incorporating into spine to speech language using deep learning. Yeah. It's our future work.
Okay, Vamsi, you can stop your presentation.
Yeah. Thank you.
Thank you, sir.
Thank you.
Moving on, I like to call Mr. Anathu S. for his paper titled Strategic Sourcing in Healthcare, a supplier classification approach for improved hospital performance. Sir, you may please start your presentation.
Yeah, sure, ma'am. Am I audible?
Yes, sir.
Give me 1 minute to share my screen.
Sure, sir.
Hello, ma'am. Can you please confirm that is my screen visible to?
Yes.
Yes, sir, it's visible.
Okay, before I start my presentation, I would like to extend my heartfelt gratitude to ICTS 24 and the organizers for providing us such an invaluable opportunity to present our research paper at ICTS Ahmedabad 24. It was truly an honor to showcase our work amidst such a distinguished audience of scholars and professionals. And once again, I really thank you for this opportunity to present our paper in such a prestigious conference of our nation. Our research topic was strategic sourcing in healthcare sector, a supply classification approach for improved hospital performance. So let's get into the paper. So as we all know that effective supplier selection is very much crucial for optimizing procurement and purchase performance in a healthcare sector. By fostering the suppliers, the effective supplier bond, we can actually align and collaboration and innovation, and also maintain the sustainability in the healthcare sector, and become a competitive leader in the global perspective. And in the healthcare sector, optimal supply selection is very much vital due to heavy reliance on timely procurement of the equipments and also its spare parts to enhance and ensure the quality of the service in hospital industry. So effective supplier relationship management in healthcare sector, including the selection of the contract, the negotiation with the suppliers, performance monitoring, risk management, and sustainability consideration. So the paper actually get into the significance of the AET model, which AET framework, which we are actually presenting, which addresses the limitation of existing model in the healthcare industry. So when we look into the present state of supply selection in healthcare industry, we can see that there is a lack of organized methodology for choosing suppliers. The selection of suppliers is typically involving taking multiple quotes from various suppliers, and the decision of selecting a supplier will be depending on the quoted price and preference of the individual who is actually overseeing the purchase or the procurement process. So there is no such standard framework for selecting the suppliers. So let's see what are the advantages if we have a supplier selection and classification method. So if we have a supplier selection and classification method, so the quality of patient care can be increasing by selecting the suppliers, that the quality of the equipments and accessories that we procure will be more, so that the quality of the patient care will be more increased, and the operational efficiency will be enhanced within the hospital facility by procuring the quality equipments and products. So, and also other benefits will be the long-term sustainability and also cost control. That effective suppliers classification help to cut the cost without compromising any quality, and also continuous innovation and collaboration, continuous improvement, and building strategies with suppliers can ensure continuous improvement in the healthcare procurement practices. So let's look into a model that is that is in the system, that is CATS 7C model and its limitations. The CATS 7C model is an old standard model which consolidating the suppliers by the 7 criteria or the 7 C's. The 7 criteria which include the competency, capacity, commitment, control, cash, cost, and consistency. But even though we look deeply into the system, we can see that the 7C model provides a structured framework for supplier evaluation, but there are limitations for this model also, because the model is not relevant, not at all relevant and satisfying the entire situation of the current situation of the industry. So and it is not at all easy to maybe customize or to adapt to change of business environment or the hospital environment that in the current scenario. So we cannot fully rely on the SCATUS 7C model. So this lead to a standardized framework for supplier evaluation, because as we say that the 7C model have some limitations, so we cannot completely rely on it. So we collaborate with one of the leading and prominent hospital in India, and with the collaboration of the evaluators, the purchase officials, the procurement officials, and of the hospital, we have pinpointed the crucial factors that could be that could serve a based on or foundation for the standardized framework. So as a result, we have introduced a novel framework which is named as the AET framework for supplier evaluation. And based on the supplier evaluation, we have created the model that is AET model of supplier evaluation. The A stands for the after sales support, E stands for the effective communication with the supplier and the hospital, and T for the technological advancement. So we have collaborated with the experts to pinpoint these crucial facts, and the necessary data that we need to analysis were extracted from the purchase inquisition brochure and the hospital information system, that is the HIS system that is used in that hospital. So we have pinpointed the criteria, and then we have to take up the criteria weight. We must need a criteria weightage for the evaluation. So the evaluation of the criteria weightage has been taken by gathering the input from the experts by in direct interviews and word of mouth. So the expert input ensure a thorough and equitable assessment for the preference, and by averaging the weightages that each evaluators and the experts given from the industry, we have refined and well adjust the set of criteria, and we have find out the weightage criteria for the A and the after sales support, effective communication, and technological advancement. So by this help of these criteria, we again collaborated with the evaluators to score the suppliers based on their previous purchase history, based on their service that they have given. The suppliers given the evaluators and the experts given scores to separate scores to each of the suppliers, and these scores will be multiplied with the criteria weightages that we have given, and based on that, then the final score is taken, and based on the final score, the suppliers are classified into Class A supplier, Class B supplier, and Class C supplier. So and while considering in a hospital industry, we can see that there will be suppliers for equipments also as a spares and accessories. So different categorization of suppliers for evaluation of equipments also, as well as spares and accessories, has been taken. And let's see the results. So the AET model actually hold a greater relevance compared to the other factors, and based on the scores that each supplier getting to that 3 criteria, we will be classifying the suppliers. So the suppliers will be classified based on the weightage assigned to these components and the scores provided by the experts. Then the classification like Class A, Class B, and Class B will be determined and based on the assigned weightages and their scores. This classification system actually enables the hospital industry to differentiate the suppliers according to their overall performance and effectiveness in meeting the criteria with the organization. So each supplier will be subjected to distinct policies and guidelines established by the organization. Because, for example, we can say that if we are taking in the purchase of a machine which costs 30 lakh rupees, there can be various policies can be given to each class of supplier, because we will always prefer the Class A supplier rather than class B and class C. If the class A supplier is not able to
Excuse me, sir. Just a gentle reminder that 8 minutes are over. So please, can you wrap up?
Yeah, sure, ma'am. We can only take into action that class A, class B, class B will be taken into priority. And by this can be served as a tool for streamlining decision-making process, optimizing the resource allocation, and ensure that suppliers will be aligned to organizational objective. And also, the framework offer a valuable benefit for the organization, healthcare organization, apart from the size, including it can be a small rural clinic or a high-end hospital, primary hospital. There is no no variation will be made by the framework for hospitals based on the bed capacity or financial. The main objective of the framework will be to ensure consistent quality care for the patients and enable standard treatment provider. So, as a conclusion, we can say that the research underscore adaptability and flexibility required in supplier selection and classification in healthcare sector, especially. So, and this criteria identified may differ. It can may vary according to the hospital and depending on the perspective of the expert who is working with the hospital. And this study also give a space to the hospital experts to enhance their performance based on the edits they can need it, and it can be customized or tailored to their hospital needs. And that these are the reference papers that we have given to which help us for the study. And that's it, ma'am. Thank you.
Okay. The question is, how does your approach account for varying the needs of different hospital departments? For example, pharmaceuticals and medical equipment.
You're sure, ma'am. In a hospital industry, we can see that there will be multiple purchase will be happening, like hospital equipment, the high-end equipments will be there, small accessories will be there. But in mostly in a hospital, the purchase and procurement will be handled by a separate department or a separate entity, or it can be a group of people, or it can be a single person who will be handling that. So the framework can be helpful to the people to classify the suppliers into multiple class to ensure and to foster a good quality of patient care and treatment to the patients by giving quality equipments and accessories.
Okay. So considering this dynamic nature of healthcare industry, how do your account for potential changes or disruptions in supply relationships and procurement practices over the time?
Yes, ma'am. As we know, the CATA 7C model will be used in the previous year, previous in the past times. But the AET model actually depends on the current scenario for what are the factors that are accountable for the current situation of in the industry. So it's actually open for changes or innovation, because the hospital, as I said earlier, the person or the department who is actually taking in account of the procurement and purchase can actually make changes, and it is free to be changed. This model is actually free to change, and it can also give opportunity to that person or the entity to make research changes that the framework can be adjusted to the hospital or the organizational needs, ma'am.
Okay, so in this CATRA 7 model, in these 7 components, what exactly this consistency means?
Means the consistency means, ma'am, if the supplier is continuously giving consistent quality, like if we want a machine or a spare part. So if and like we will be ordering in multiple times, like 100 unit of an accessory now, and 100 unit in next month, and 100 unit in once again. So if the supplier is consistent about delivering and committing that order in a timely manner and in a full amount. Maybe some suppliers can deliver 100 at this time, but short of availability of or over demand of the accessory, the supplier may be not able to deliver 100 in the next month because of the over demand of that accessory. So there will be a lag of consistency in the delivering goods to the hospital, and it can also lead to a lag in the process in the hospital industry. So that means the consistency of the supplier.
Okay, so does your research offer any quantitative data or case studies that demonstrate the impact of strategic sourcing on key metrics like cost saving or quality improvement?
We actually gone for the prominent hospital industry, ma'am, and we have done sitting with the experts there, and with the help of that expert, we have actually get the all type of data from their HIS system, and also it is open to be for experiments, and it can be more beneficial for the supplier selection and classification.
So it is cost saving?
Yes, ma'am. It is actually cost saving and also beneficial for the organization in the current scenario.
Okay.
Because one more point, can I add?
Yes, yes.
By the classification of suppose the suppliers are classified as class A, class B, and class C. So the first priority of an order will be always given to the class A supplier. So there we are actually creating a competition in between the suppliers, that the primary importance and the extra benefits will be given to the class A suppliers. So we are forcing the suppliers, the class B and class C suppliers, to get into class A to get more orders and more benefits. So we are actually forcing them to give more quality services, more benefit to the hospital, so that they can be added to the class A supplier and they can get more orders from our hospitals.
Okay, Ananto. You can stop your presentation.
Thank you, ma'am.
Okay, so moving on next. I'd like to call Miss Sanju Kaladharan for her paper titled Strengthening Health System Towards Dynamic Sustainability. Ma'am, you can start now. Ma'am, can you start your presentation, please?
Yes, I'm trying to share my screen. Is it visible?
Yes, ma'am.
Okay. A very warm good morning. Thank you, first of all, thank you to ICTIS for giving me an opportunity to present my paper. Myself, Sanju, and I'm an early researcher and a PhD scholar at Ahmedabad School of Business Coaching. And today I'm going to present my paper, my research on strengthening health systems towards dynamic sustainability, which is co-authored by Dr. Tanya, Dr. Vishwanathan from Ahmedabad School of Business, and Ms. Krisha from St. Lawrence College, Kingston, Canada. Thank you for their support as well. I would like to acknowledge at this point of time. And as mentioned, the title of my paper is Strengthening Health Systems Towards Dynamic Sustainability. And to start with, access to healthcare is one of the prominent target of United Nations Sustainable Development Agenda. So what accessibility means, it consists of parameters like availability, which means that all the requisite resources, person and technology to fulfill the needs of the patient should be available, and people should there should be accountability, affordability, and acceptability. So these parameters together constitute the variable of accessibility. But what happened during COVID, the public health systems were under shock, and they were not able to find ways to mitigate the health emergency because there were limited resources, infrastructure, and restrictions, which include social distancing. So during COVID, the hospitals were dedicated entirely for the COVID-19 management. Even the open field schools, everything were converted into the COVID care centers. So the people suffering from the other diseases like non-COVID diseases like diabetes, cardiovascular disorders, cancer, they were not able to get proper access to healthcare service. This is actually a problem because we are not able to manage the health emergencies like COVID. So the lessons learned from both waves of the pandemic, that is the first wave which has happened during 2020, March 2020, and the second wave during March to May 2021. So they give all lessons to learn from the disasters and health emergencies and elevated patient surge and research requirements. So in order to address that, this is a conceptual paper in which a model is conceptualized for responsive and adaptable health system, which integrates 3 frameworks. The first one is the WHO Health System Framework, which was formulated by World Health Organization 2010, which gives all the necessary requirements or the desirable requirements for a health system to function. And the second one is Dynamic Sustainability Framework, which was given by Chambers et al. In 2013, and TAPIC framework, which was proposed by Greer et al. In 2019. So all this together, we are formulating a conceptual model. I will be explaining one by one by taking on to the lessons which we have learned from the Indian context. So first of all, this is the WHO Health System Framework, which is made up of 6 building blocks. That is, the first one being the service delivery. The second is health workforce, the health information systems, access to essential medicines, financing, and leadership governance. Together, WHO proposes that these together can provide improved health, the responsive healthcare system, social and financial protection, and improved efficiency. And the second one being the dynamic sustainability framework. In this framework, actually, there are 2 situations which has been explained. The first one being the program drift. So whenever there is an intervention or a program being designed, the program drift indicates that the standard protocols will not be yielding the same or the expected benefits as we are expecting, and we might deviate from the standard protocols while implementing in the real time. For example, if we are preparing anything that we have a protocol to be followed during the next disaster, it will not be having the same benefits when we are implementing in the real time. So the second one is that the voltage drop. That means the interventions delivering the benefits when they move from the efficacy to effectiveness. As you can see in the diagram, so when the time passes, like the first is the trial period, first we will be seeing whether it is efficacious, the next is effectiveness. So during that course, what happens, the results or benefits will be reduced over time. So during this, what happens, what we are planning will not happen when it is implemented in the real time. So first, we will be actually seeing what each constitute for. For example, the first one is the service delivery. So what we are proposing is that the regional health systems should be strengthened, because during the COVID situation and all these local governments and all, they work together. So the regional healthcare system was strong in the healthcare sector in India. Then digital health interventions like e-Sanjeevani OPD and all, they came into existence during COVID. And to ensure social sustainability, that means even if we are promoting any digital health systems, it should be usable by everybody. There should not be any gap. For example, the elderly people and all must be given provisions to access these kind of systems. The second one is the health workforce, that is the training and development and providing financial incentives and working environment for the health workforce so that they can, well-trained staff are retained in the system. And also using the community health workers. So a notable example in India was the use of the community healthcare workers, that are ASHA workers, so that during the COVID, which was appreciated by the global communities as well. The third being health financing. That means, which is one of the most important goals in United Nations Sustainable Development Goal, that is health insurance coverage must be provided to everybody in the country by the government, so that many partnerships are there with the WHO, World Bank, etc. And there's an initiative known as Samruddh given by Government of India to enable blended financing in healthcare sector. Then the access to medicines. We all know that India is known as the pharmacy of the world, and we are producing the medicines which is distributed globally, and it was really helpful during the COVID. And there are non-health partnerships where many NGOs and other corporates came into picture to deliver like health deliveries like oxygen cylinders, etc. And the financial health coverage for the medicines. Next is the health information system. It should be sustainable and interoperable, and there should be periodic upgrade in the health information system. For example, we have in India, we have Ayushman Bharat Digital Mission. The structure of the unified health interface is given here. So here there are many applications in which everything is linked together. So if we go from one hospital to another hospital, also that is interoperable. All our history, prescription, everything will be visible in our unified ID that is linked to the Aadhaar card. So this kind
Ma'am, just a gentle reminder that 8 minutes are over. Could you please wrap up?
Sure. Thank you. Thank you for reminding. The last one being TAPIC. The systems should be transparent, accountable, and the participation of all the decision makers must be ensured. It should be integral. The integrity should be maintained, and there should be policy capacity. So that is what is known as TAPIC framework. So bringing all this together, what we are proposing is a governance-centered framework, which will be actually, if it is a government-centered framework, we propose that there will not be any program drift or a voltage drop. So this is the picturization of the framework. So from the study, it is concluded that the access to healthcare was reduced during the pandemic. We did this on the literature review, and the healthcare was not resilient enough to the consequences of COVID-19 pandemic. To overcome this, we propose the health systems must focus on dynamic sustainability. That means whenever there is a change or an external shock, they must be able to withstand. A governance center framework integrating various building blocks is put forward. It is recommended to deepen this line of inquiry, considering lock and context enablers and barriers for a resilient health systems. These are the references, and thank you.
Okay. Yeah, a question for you is, in your TAPIC model, what
Yes,
is the
ma'am.
exact meaning of this integrity and the transparency?
Integrity, okay, transparent that the decision makers might be like all the decision must be transparent, like what we need and what to be done. So for example, in our case, it's not a federated health system. So we have state health systems and a central health system. The communication must be transparent so that it will be really effective between the decision makers. And the integrity is like what each people have to do and how this will be coordinated will be integral. That is, it's a collaborative.
Okay. So you mentioned that various Indian initiatives like e-Sanjeevani, Pradhan Mantri Arogya Yojana, then
Yes.
Ayushman Bharat Digital Mission. So how do these initiatives contribute to enhancing the resilience and adaptability of Indian healthcare systems, particularly in the face of global health crisis?
Actually, if you see the history, there are in context of healthcare, there is neoliberalism, which means it was almost privatized. The government control was less. But in our case, after 2015, all this, following this UN SDGs, all the countries are developing their initiatives to fund their citizens for healthcare. So when it is done, the most, for example, the people were not able to finance themselves during the COVID-19. However, our health systems, even for Ayushman Digital, but this is in the development stage though. So they all were providing when there is absence of healthcare system, like for example, during the cancer patient was able to use the healthcare even during the pandemic. So actually, this was appreciated, and it was a quick response from the Indian government. For example, the COVID app. So everything was quite spontaneous and it made the health system adaptable and people were able to access the healthcare. So that is what we're trying to incorporate into our research.
Okay. So what exactly the key principles or characteristics that defines dynamically sustainable health system?
Yeah, dynamically sustainable means definitely if there is one health system or the pre-structured health system, it will be sustainable throughout the time. Like when there is an external shock, if the features are still adaptable, that is what we are meaning by the dynamic sustainability. For example, ASHA workers, they're actually normally used, first being used for screening the pregnant ladies in the villages and all. But having them was an asset during the external shock of COVID. It was easy for them to train, for the health system to train them and to go and track the COVID-19, especially in the rural areas of India. So we have that structure, which is quite sustainable over the time during the external shocks as well. That is what we mean by the dynamic sustainability.
Okay. Okay.
Thank you. Thank you.
Thank you, ma'am. Moving on to the next presenter, I'd like to call Mr. Tanmay Valke for his presentation titled Suggestosphere, a sport recommendation system. So you may please start now.
Yeah. Am I audible?
Yes, sir.
Um, yeah. So, is my screen visible?
Yes, sir.
Yes.
Yeah. So, starting off, hello everyone. I am Tanmay Valke from Vishwakarma Institute of Technology, Pune, and our research paper is Suggestosphere, a recommendation system for sports equipment. So, these are the list of the other authors who have contributed in the paper. So, moving on, these are the contents of our presentation. So starting off with problem statement. So our main aim was to develop a recommendation-based system by integrating with the Google's Map API for basically tracking the location of the users and web scraping the sales information and for a trend analysis in order for to offer the customer the best affordable products at the best time and also inform the users about the current sales time of the different brands. So features include brand featuring and their sales tracking, trend analysis, user reviews and ratings. Moving on, our objectives are, first of all, the data collection and pre-processing by consistently increasing the accuracy of the model. Then the main algorithms are collaborative filtering and context-based filtering in order to identify the user's historical data and identify trends in their patterns, and also classifying the different products of the different sports recommendation websites and giving the real-time insights to the user. So importance of recommendation system. This tool shall also help upscaling the businesses of the different sports companies and increase the customer loyalty and satisfactions as they can choose their product at the very cheapest price and at the time of the sales and also increasing the sales of the businesses. Coming towards the proposed system, so this is how our flow of website goes. First of all, there will be user authentication about the login ID and password. Then their location will be tracked. And then the different data sets with the sales data and the different products data from the different sports recommendation websites like the Puma, Adidas, Nike, Reebok, etc. will be gathered. This data will now be pre-processed and will undergo under the three basic algorithms, which are the context-based filtering, cluster formation, and collaborative filtering. After which, we will notify the users about the current sales period of that company. Coming towards the implementation of the algorithm, first is the content-based filtering, in which we had used feature extraction to extract the features of different sales data, then user profiles, product representation, similarity calculation, and then generating the recommendation to product. Moving on, the cluster formation. This basically used for selecting the relevant attributes and normalizing them from the data that is scrapped from the different websites. The feature selection. We'll be identifying the features for the clustering based on the product categories, brand names, and discounts. After which we'll be applying the clustering algorithm, if like the hierarchical clustering, so the similar products together, and then labeling the cluster, identify the different characteristics among the cluster, and then we shall recommend. Coming towards the third algorithm, which is the collaborative filtering. It is basically a matrix-based algorithm, just like a database, where we create the rows representing the users and columns representing the products. And then we will be identifying the similarity calculation based on the interaction. Then after which we'll be applying to the neighborhood selection, which is applying the KNN model to find out the nearest neighbor for each target and assigning the similarity scores. And then after which we'll be generating the predictions to suggest the users like which product they can buy at the cheapest time and what is the sales time. After which we'll be generating a recommendation. Coming towards the data acquisition and analysis, like customer preferences, geolocation, and heat map sales data. In customer preferences, we'll be collecting the data on what customers are interested in and what they can purchase, providing the insights. Then in geolocation, we'll be tracking the location of the users in order to track the nearest factory outlets near the user and suggest them to buy the product by going to that location. And then sales data. We'll be tracking the sales data of the different users and also of the companies, like suggesting the users on which company's current sale is going on so that they could buy the recommended product. Coming towards the component used, the basic tools used are HTML, CSS,
Sir,
JavaScript.
just a gentle reminder that
Yeah.
8 minutes are over. Could you please wrap up?
Yeah, so these are basically the components used. And the benefits includes the customer loyalty and also the sales revenue increase and customer experience. Concludingly, the recommendation system could be a big benefit for the local business in the sports industry and driving their sales revenue. These are the references, the research papers that we had studied. These are just a few of them. And yeah, done. Yeah. So
Okay.
any question and answers?
Yes, Tanmay. In your system, in your steps, if you skip either collaborative filtering or a content filtering, is your system work properly?
Actually, the main advantage of using the collaborative filtering is to basically classify the product. So we won't be able to classify the product. We'll be able to scrap the data, but without these algorithm, it won't work.
Okay. So what is the exact difference between collaborative and content filtering?
Yeah. So like I shall show you the slides. First of all, in basically in context, we will be extracting the features. Like these are the things that we have implemented for the user profiles and analyzing the historical data of the users and representing the products. But in case of the collaborative filtering, we'll be using the matrix type of structure, analyze the data. In collaborative filtering, basically recommends items to users based on the preferences of the other users. Whereas in the context-based filtering, it recommends items based on attributes or the features of the item and based on the user's past preferences. Which basically collaborating language is
Okay,
does not
okay, okay,
require.
okay, Tanmay. Okay, okay,
Yeah,
fine. You in your system, you mentioned that your main feature is real-time adaptability. So
yeah.
how you can say that it is real-time adaptability?
Because like we are scrapping the data on the website in every 10 minutes. We are using some tools for it, using the Selenium library of the Python. So after each 10 minutes, the data will be revised, the price of the products or the which sales is going on. For example, Puma introduced a new, like after 12 o'clock, for example, they introduced the Black Friday sales or some different types of sales. So we'll be updating after each 10 minutes of our website.
After 10 minutes.
Yeah.
So we can say that after 10 minutes, it is a real-time adaptability.
Yeah, because normally the data doesn't change normally till 1 day also or up to few hours. Like the sales normally get introduced like at 12 o'clock midnight normally. So it doesn't affect much. Still, we had like kept a 10 minutes data for some of the certain products. Normally, it takes almost an hour or two, couple of hours for the price of the different say change or introducing a new sales. So that's why it works like a real time. And updates we give like as soon as the sales start, we give like directly the user is notified. They get a mail.
Okay. How does your system address the potential for data sparsity, especially for niche sports or new users with limited purchase history?
So for the basically for the new users, they can create a login. Of course, we'll need some historical data to classify, but maximum whatever recommendation system does is that those who are the maximum users on a website, we take their data set and then suggest the new users in order based upon the previous participants, like similar products. Then after which, if the user selects any particular of that recommendation that we had suggested, then we keep on suggesting more as their industry increases. So basically, that collaborative filtering helps a lot in that process.
Okay, Tanmay, you can stop your presentation. Good.
Thank you, sir. Moving on to the next presenter. I'd like to call upon Mr. Pratik Bulgave from Pune Institute of Computer Technology for his paper titled Techniques for Knee Osteoarthritis Detection and Severity Grading Using Deep Learning. So you may please start now.
Am I audible?
Yes, sir.
My screen is visible.
Yes.
Yes, sir.
Yes. Good morning, everyone. I am Pratik Goregave, and I am from Pune Institute of Computer Technology. My co-authors are Abhijit Sonmore and S.S. Vasekar. Today, I am presenting that topic: techniques for knee osteoarthritis detection and severity grading using deep learning. These are my today's agenda. Generally, osteoarthritis is a widespread musculoskeletal disorder that primarily affects the elderly and overweight individuals. It targets joints starting in ligaments and progressing to cartilage deterioration, resulting in joint pain and stiffness. Uh, Knee osteoarthritis is a common form, ranking fourth in global disability cause. It leads to the gradual knee cartilage corrosion and causing pain, swelling, and mobility reduction. Uh, in the literature survey, we have gone through various research papers uh, for which in which we have gone through various machine learning and deep learning algorithms. A few of them are that different deep learning algorithms studied are artificial neural network. Its artificial neural network works is a computational model which works like our human brains and human nervous system. Another one is the random forest classifier. It is a decision tree based algorithm. Then next one is k nearest neighbor. It is a non-parametric. It is a non-parametric machine learning model, supervised machine learning model, which is generally used for classification and regression techniques. Next one is the convolutional neural network. It consists of various convolutional layers, pooling layers, activation functions, and fully connected layers. Next one is RCNN. It stands for Regional Convolutional Neural Networks. It is a extension of the convolutional neural networks. Next one is the DenseNet architecture. It is also an extension of the convolutional neural network. It stands for the dense convolutional neural network. It consists of various dense blocks followed by the transition layers, but the last dense block is followed by the average global pooling layer and a softmax layer. Next model is the exception model. It is a deep 71 layered neural network. It is the extension of the CNN. This exception model we have implemented to solve our problem. This is the problem. The problem definition is to detect the knee osteoarthritis and severity grading by studying the posterior anterior view of the X-ray images of the knee using deep learning. The objectives of the problem objectives for the project are to collect the large quantity of the data, then to process the data set uh, by using various techniques. Third one is to classify the images into the different categories of the knee osteoarthritis basing on its grading, and last one is to detect and finalize the severity grading. This is the methodology, means how the system works. First one is collecting the images, collecting the data set. Second one is data pre-processing technique, means it includes computation of the class weight and pre-processing images to make the suitable for applying exception model. Third step is model implementation. As we are implementing the exception model, it is a extension of CNN. Next step is to calculate the accuracy scores and balanced accuracy scores for the model. Further step is to testing the model, and last one is to deploy the model and serve the output uh, as a grading system. A few of the partial results are we implemented the exception model on the two different data sets with different number of images. Data set 1 contains the 455 images, and data set 2 contains the 857 images. For the data set 1, valid loss is 3.2695. For valid accuracy 0.40, valid accuracy score is 0.40, and valid balanced accuracy score is also 0.40. For second data set, valid loss is 3.5985, valid accuracy is 0.537, and valid accuracy score is 0.54, and valid balanced accuracy score is 0.45. uh, these are the graphs of the model accuracy and the model loss. As we see the graphs, as the number of epochs increases, the accuracy of the model increases, as and number of epochs increases, the uh, model loss goes on decreases. So we can conclude from this graph that if we increase the number of epochs in our implementing model, then we can get higher accuracy. This is the confusion matrix which calculates the accuracy of the system. Generally, our algorithm classifies the images into the 5 categories, that is severe, moderate.
Excuse me, sir. Just a gentle reminder that 8 minutes are over. So can you please wrap up?
Yes. This confusion matrix tells the accuracy of the system. Then conclusion, for this, we studied the different image classification techniques, implemented exception model on different algorithms. The accuracy of the exception model is higher as compared to the other classification techniques, and it takes lesser processing time as compared to CNN and other deep learning techniques. Accuracy increases with increasing data set. In future, we can do the data augmentation techniques in order to increase the size of the data and increase the accuracy of the prediction. These are the references that we have referred to. These are the latest one. Yeah. Thank you.
Okay. Pratik,
Yes.
you mentioned the knee ligaments. So did
Yes.
you incorporate the features related to ligaments alongside this cartilage analysis in deep learning models? What are those features?
Generally, ligament is nothing but ligament is nothing but our joints are our bones joints are connected to each other. To avoid the friction between the joints, we use the ligament. One of the ligament, that is a cartilage. It generally absorbs the shock to avoid the means friction of the bones from each other, and if the friction happens, then there will be the gapping between the bones, and due to that gapping there will be the knee aches, so that it is a shock absorber, we can say, yeah, as a feature.
Okay. Uh, what are the challenges or limitations that researchers encounter when developing and implementing machine learning techniques for this knee osteoarthritis detection and severity grading?
um, and collection of the data, because we need to collect a large number of the data for processing, because we cannot implement the system on a very smaller size of data, so collecting the data set was the first challenge. Mm, and it may sometime it may predict wrong results also, because it is a prediction, that is so we will have to work on the accuracy to get more and more precise predictions. That these are the two challenges, I think.
So from where you got this data set? What is
uh,
the size of your data set?
Generally it consists of 8,000 images. Here we have shown only partial implementation. The data set is obtained from Osteoarthritis Initiative. It is a worldwide research center. From that research center, we have obtained this data set.
Okay. ठीक है प्रतीक. You can stop your presentation.
Okay, ma'am.
Thank you, sir, for your presentation.
Thank you. Yeah.
Okay. Yes, audible.
I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of Global Knowledge Research Foundation and ICTIS, we thank you all, and we will be happy to see you in the 9th version in 2025. All the presenters will be getting the digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live in 6 months. Now, I'd like to thank our session chair, Poonam, Ms. Helkar ma'am.
Yes, thank you, Richa ma'am. Actually, I'm truly honored to stand before your session before your
This is
session chair.
a token of appreciation.
Thank you, ma'am.
From ICTIS 2024 and Global Research Foundation and partners. Thank you for your valuable presence. Now, I'd kindly request everyone to switch on the camera for a quick snapshot for the virtual conference. Everyone, can you please switch on your cameras? Thank you, everyone. Stay safe.
Yes, thank you. I want to give some remark on for all the presentations. Firstly, I would like to thanks or extend my gratitude to all the presenters who have shared their groundbreaking research and innovative ideas through their research. The paper I have reviewed cover wide array of topics, showcasing the depth and breadth of knowledge within this ICT community. From the advancement in healthcare system with cutting edge recommendation system and techniques for knee osteoarthritis detection using deep learning to transformative shifts in e-commerce with personalized sports recommendation systems. So each paper has offered valuable insights into the intersections of technology and various domains. I have delved into critical issues such as sustainability in health systems, support systems for deaf community, and strategic sourcing in healthcare procurement. So your research highlights the importance of leveraging technologies to address complex challenges and improve outcomes in diverse fields. So as a session chair, I'm impressed by depth of research and dedication demonstrated by all the presenters. So once again, thank you to all the presenters and attendees for your participations and contribution to this 8th international conference on ICT for intelligent systems. Thank you, and I hope this session is fruitful to all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.